Hi everyone, I am Ankit Suvarna. Today I will be sharing my project work on healthcare analytics using Altair AI Studio, which is a no-code ML platform. This project is a part of the Altair Data Science Contest. I will give a quick overview of the software and explain the work I will do. Motivation for this work is many people suffer from heart disease, and according to global statistics, a large number of deaths are caused by ischemia heart disease. This dataset is taken from World Health Organization (WHO). In fact, between the year of 2020 to 2024, heart disease, particularly heart attacks, has been one of the leading causes of death worldwide. By seeing some statistics, most of the people dying in heart attack, this dataset also available in on websites. Our aim is to, by detecting risk factors early and taking appropriate preventive measures, we can significantly improve the quality of life and even save lives. In this project, instead of deploying a model to a system, we use it as an like an expert system. The goal is to identifying hidden patterns within the dataset and provide insights that can guide better healthcare decisions. Dataset information. Dataset is taken from Kaggle. It is a openly available dataset. The name of the dataset is heart disease dataset. It is in CSV file format. It has total 918 rows. That means 918 data entries of a patient, and it has a 12 features. That means 12 columns. Here target variable is 2. Basically it is a binary classification. Here 0 means it is a normal. 1 means it is a the person has heart disease. Here feature data types are 3, that is integer, float and categorical. Before performing the data analytic task, we have to upload the dataset to the Altair RapidMiner. After uploading the dataset, we have to do some pre-processing techniques like clean the dataset and modify the dataset. This process can be carried out in a blank process. In a blank process, at the top ribbon, there is a one option called Turbo Prepare. Okay, in that option we have modify the dataset. The data analytic task is important because it tells the how the different features are important for predicting the heart disease, and it also explore the hidden patterns in the data with some visual representation of these plots. Correlation heat map, it should be help to identifying strongest and weakest feature in our dataset. It can helps to select some input feature for building a ML model. In this case, we identifying some strong, moderate and weak correlation. First, ST slope down versus heart disease. It is negatively correlated. It has minus 0.6222, and next one is the ST slope up versus heart disease. It is 0.0554 correlation, and next one is the chest pain versus heart disease. It is 0.517 correlation. Next one is the moderate, is the age versus heart disease. It is 0.282 correlation. Next one is the weakest features are sex versus age. It is 0.056 correlation, and next one is the resting ECG versus heart disease. It is 0.11 correlation, and another one is the cholesterol versus age. It is minus 0.095 correlation. In this case, we have also neglect the less correlation features. for building a ML models. Column chart, it gives the information of whether a data set is balanced or not. For building a machine learning model, balanced data set is essential for accurate prediction or classification. In this figure, we see that there is a above 400 are normal people, and above 500 are deceased people persons data are available in our data set. This histogram plot shows the which type of chest pain is common in deceased people. From this plot, we see that ACY and TA being the most frequent type of chest pain in deceased people. From this scatter plot, we plot age versus maximum heart rate. In that case, red dots are indicates the disease and blue dots are indicates the normal. As seen at the correlation matrix, maximum heart rate is negatively correlated to heart disease. That means they are inversely related. If the person has lower the heart rate, then the chance of heart disease more. As seen from the plot, high age people has lower maximum heart rate, so chance of heart disease more. But it only feature 2 we do not decide directly. We require more feature. Box plot is plotted with the help of ST slope versus age. ST slope has three types: up, flat and down. ST slope is generated with the help of a ECG test. ECG test is cheaper than echo test, but echo test it gives the more information compared to this. Up slope is varying between age about 25 plus to 70 plus. Similarly, flat ST slope is present between above 30 plus to 70 plus age, and down slope is present between above 35 plus to 70 plus age. Here ST slope is also varying age to age. I have made some critical insights about data analytics. These 5 points are I already explained in a data visualization slides. The analytics shown nonlinear patterns in interaction between age, maximum heart rate, like these features, which justifies using tree-based models like random forest XGBoost rather than only linear models. Basically, in some research work, ensemble learning models gives better performance compared to classical ML models like support vector machine, linear regression, k nearest neighbor, etc. I built totally 6 machine learning models using Altair RapidMiner without any code. Let's see how to build this machine learning model using RapidMiner without any Python code or any code. First, okay, in this process, first we have to select the blank process. After selecting the blank process, we have to drag and drop our data set. After that, in a left panel, there is one option called operator. In the operator panel, we have just type normalize, and there is one block is present. Normalize. It should be we have to drag and drop in the blank canvas. After that, we connect data type with the normalize. Actually, I in this process I select Z transform as the normalizer, and I click on the normalizer. In the right side there is a parameter panel is opened. In the parameter panel I select attribute filter type as subset, and I select some features. Okay, which feature has to be normalized? I select age, resting BP, cholesterol and maximum heart rate. After this I have to similarly I drag and drop nominal to numerical. Basically here sex is the nominal feature. I have to convert this to numerical, means male has get 0 value and female get 1, like this. And after that I drag and drop the numerical to binomial block. Here I select attribute filter type as single, and feature is heart disease. Basically it is the label. We have to predict heart disease present or not, therefore I do this. After that I have to drag and drop the set role. Here in set role I click on that. There is in right panel there is a edit list option will be present. In the edit list we have to select attribute name as heart disease, and set the target role as labeled. After that, in every ML model, we have to split the data for training and testing. Basically, training it contains more data compared to testing. Okay. After the splitting data, we have to drag and drop the model. Basically, we require which model. Basically, logistic regression means logistic regression block or SVM. Any block is present. I take logistic regression block and I give training data to the model and testing data to the apply model. After this, all the setup is done. Next, I drag and drop the performance. In model, there is also some hyperparameter is present, like in random forest, how many trees there, and logistic regression, how many iterations are there. Like many hyperparameter will be present. Same splitting data is also a user friendly. It should be decided by the user based on its performance and accuracy. After that, I select here performance as binomial classification. Here, I select some performance matrices like accuracy, precision, recall, F1 score, etc. And I connect performance to a result and run this process, and I get the result at the result window. These are the some steps what I already explained in our previous slides. I make one algorithm to explain the entire process what I did to build a model. It involves totally 10 steps. It is the table for the confusion matrix, which is generated for the logistic regression machine learning model. This confusion matrix consisting of a true positive, true negative, false positive and false negative. Based on this confusion matrix, we also manually calculated precision, recall, F1 score and accuracy also. We also build one hybrid and stacking model. Basically, hybrid model means it consisting of more than one ML model. Basically, in this case, we use base learner as logistic regression, gradient boosting or XGBoost, and k nearest neighbor, and stacking model as random forest. The goal is to improve the prediction accuracy and also improve the generalizability of a model, and eliminate the problem of overfitting. It is the one schematic view of the hybrid model. In this case, the step are same what we followed in previous to build the ML model, but here one additional step is we simply drag and drop the stacking layer. Inside this stacking layer, it consisting of a base learner and stacking model learner. Okay, these are the blocks inside the stacking layer. It has the base learner as gradient boosting, k nearest neighbor and logistic regression, and stacking model as random forest, and it is connected to next node. In this case, we try a different combination of models and we get a good result for this combination. It is a model performance table. We totally built 7 models. In 7 models, 6 are the individual model and last one is the hybrid model. In all model, logistic regression model gives the better performance compared to other model, and decision tree is the worst. Here hybrid model gives the moderate or decent performance. Always getting a good result is not only the consideration but how the model make a generalizability for the new unseen data. It also matter. Sometimes there is a possible that the model must be overfit. Therefore, it gives the good result. So, hybrid model is also always preferred. It is the radar plot. It should be generated with the help of a Excel sheet for the performance of the model. Auto model option present at the top ribbon of the blank process. It should be used for rapid prototyping. Here we can make prediction, clustering and identifying outliers. This option present at the auto model. First we have to load the data. After loading the data, we have select task. Here task is prediction, clustering and outliers. I select prediction. After selecting, I set the one target. Here target is label target like heart disease is our target, and select target. Next I select some inputs. I select this input based on the correlation matrix. Here low correlations are neglected, and I select one model types, which model we require, that model I have to select and run the process, and the result which are displayed here. Here all the summaries are there like model, weight, simulator, performance, prediction chart, prediction model, all the details are available, like different model detail also available. Okay. This is the window of clustering algorithm. Here also we build in auto model. Here select the task as clustering. Here also we prepare the target and select the inputs and model type. Here model type is k-means and x-means, and run the process and we get the result. Here cluster 0 is the heart disease and cluster 1 is the normal. Here maximum heart rate is 15.86. Here maximum heart rate is 18.89. Like we here also related result is there like heat map, scatter plot, centroid table like this. It is the scatter plot. It is the result of our cluster. Here cluster 0 is the heart disease. Here cluster 1 is the normal. Here also jitter amount is there. If we move the jitter amount towards, these data points are come closer. We make some critical insights about these ML models. We compare many algorithm and we get logistic regression is the best classification algorithm. We also build a hybrid model, and random forest and XGBoost is the less specificity. This problem can be solved with the hybrid model. It is the not overall best, but it's a still decent model. Altair's auto model provides quick baseline performance without manual tuning. Clustering with k-means add an unsupervised learning layer to explore patient subgroups. Combined EDA, supervised, unsupervised, and auto model in one workflow to gain a deeper understanding of hidden patterns. Some conclusion about the work: build a predictive models for heart disease detection, compare ML models plus hybrid stacking approach, validate with clustering and auto ML insights, demonstrates healthcare analytics potential using no code AI platforms. Some of the advantages and disadvantages of Altair AI Studio for ML work. First, it is a drag and drop approach. There is no coding is required. The building blocks are already available. No coding that are required. Simple process. Best suited for small to medium data sets. It is a fast, beginner friendly, and great for contents, healthcare demonstration. Some of the disadvantages is it has limited hyperparameter tuning, like basic options. It has restricted flexibility, cannot build custom models like convolutional neural network, long short-term memory transformers. Visualization is not good as Python libraries like Seaborn and Matplotlib, and it is not uh, used for deploying the model, like say in Python there is a some platforms like TensorFlow Lite, TensorFlow JS, and TensorFlow Hub, and extended TensorFlow libraries are there, but here not like such options are not there. These are the some demerits of this Altera AI Studio.